Light is a form of electromagnetic radiation. It travels in waves. Pass white light through a prism and it splits into a spectrum of colours. Violet light has a wavelength of 400 nanometers. As the wavelength increases, the colour of the electromagnetic radiation changes. Red light has a wavelength of 700 nanometers. But is there anything beyond the visible spectrum? This probe is sensitive to electromagnetic radiation, including wavelengths which we can't see. Moving outwards towards red, it shows an increasing response. But this response is even greater for some distance beyond the edge of the visible region. This invisible radiation is known as infrared. The sun emits both visible light and infrared radiation. The only way our bodies can detect infrared is by its heating effect on the skin. Although we can't see it, we can use devices which can. A light bulb looks a cool blue through an infrared camera. Switch the lamp on, turn the voltage up slowly, and the filament begins to emit heat. Heat shows up as white on the screen. When the voltage is low, the bulb doesn't glow, but it's still getting hot. This camera sees the heat long before the light emitted from the filament on the left is visible to our eyes. Emergency services, like the police, use similar cameras for surveillance at night. It's too dark to see anything, but the camera picks out a person's body heat, which this time shows up as black. The electromagnetic spectrum is a continuous spectrum of waves, from very short waves at one end to very long waves at the other. Visible light is just a tiny part of it, with a wavelength of between 400 and 700 nanometers. Infrared radiation has a longer wavelength than visible light. It has a wavelength of about a millimeter. Further along the spectrum, the wavelength increases to about 1 centimeter. This is called microwave radiation. Like all electromagnetic waves, microwaves carry energy. This energy is absorbed by molecules in food and water, so can be used for heating and cooking. Microwaves with a different wavelength are used for carrying information through the air. The output from this CD player is converted into a signal. A series of microwaves then carries the information from the transmitter on the left to the receiver on the right. A hand is enough to block the waves, as is a sheet of metal. But just like light waves, microwaves pass through glass. Microwaves are transmitted across country or relayed via satellite. Many TV and telephone signals are sent in this way, but the wavelengths used are different from those which heat up food. Beyond microwaves are radio waves. These have the longest wavelengths in the electromagnetic spectrum and carry the least energy. Typical wavelengths lie in the range of 100 to 2,000 meters. Radio waves are emitted from aerials in all directions, but because they carry so little energy, they're virtually harmless. These rocks look ordinary enough, but shine ultraviolet light on them and they begin to glow. They fluoresce. The same thing happens when UV light falls on other objects too. Tonic water contains quinine, which fluoresces. And washing powders, which contain chemicals called optical brighteners, make garments look whiter than white. Ultraviolet light isn't part of the visible spectrum, so our eyes can't see it. It lies beyond violet. But we can detect its presence by the effect it has on fluorescent materials. When UV radiation falls on these rocks, its energy is absorbed. It's then re-emitted at a wavelength we can see, which causes the glow. Invisible radiation is effectively shifted into the visible region. Fluorescent tubes rely on this shift. The tube is painted with a substance which fluoresces when bombarded with UV rays. Without a coating, all you see is a small amount of visible blue. The remainder of the radiation is invisible until it strikes the fluorescent coating, which converts it into light we can see. Sunbeds use ultraviolet lamps for tanning. But UV carries more energy than visible light. It can be damaging to skin cells, so for safety, it's important not to use sunbeds too often. The sun also emits ultraviolet. The highest energy UV rays are absorbed by a chemical in the atmosphere called ozone. But in areas of the world where the ozone layer is thinner, damage to skin cells is on the increase. The electromagnetic spectrum is a continuous spectrum of waves, from very short waves at one end to very long waves at the other. Visible light is just a tiny part of it, with a range of wavelengths between 400 and 700 nanometers. Ultraviolet radiation has a shorter wavelength than visible light. It has a wavelength of about 100 nanometers. Beyond UV, the wavelength is even shorter. X-rays have a wavelength of about 1 nanometer. They carry a lot more energy and are much more harmful. But X-rays have some important uses, helping us to observe things we can't normally see. At airports, a machine shines X-rays through your luggage. Although X-rays have enough energy to pass through most things, they can't penetrate dense materials like metal. An image of what's inside the baggage appears on a screen. Headphones and scissors become obvious. X-rays have medical uses too. This time, X-rays are being used to bombard the patient's body. They pass easily through flesh, but are stopped by bones or special liquids which the patient drinks. Areas where the X-rays had difficulty making their way through the patient show up in white. Beyond X-rays, at very short wavelengths, are gamma rays. Their high energy means they can penetrate almost anything. This can make them dangerous, but in small doses they're used in medicine to help us see inside the body. To check the blood flow through this patient's brain, he's being given a gamma scan. The first stage is to inject a gamma-emitting substance to the targeted part of the body. The patient is then positioned near to a special camera. Gamma rays emitted from inside the body pass through the skull and are picked up by the gamma camera. It detects the intensity of the emission and maps out the blood flow. Areas which are rich in blood are coloured orange, and those with little blood, blue. This blood flow is normal.